What should we do on this one?
Well, Nate has a preferred method.
I understand Nate has a preferred method, but Nate's preferred method is the longer of the two. Does anybody have the shorter of the two they'd like to explore with us? What?
Substitution.
Substitution? What kind of substitution?
You.
Okay, raise your hand if you did this problem successfully. You're the only one that you kind of, maybe, sort of? Okay, did anybody look in the answer book to see what it suggested you do? So do you want to suggest what I should do?
Yeah, let u equal 2x.
Oh, let u equal 2x. So this is one thing we did before. The reason you like that, and just this is the investigation you can do. 4x squared is 2x squared. It's 1 minus something squared. We like 1 minus something squared. If you do that, if you do let u equal 1 minus u equal 2x, you know, du is equal to 2 dx. So what does dx equal? Du over 2. So when you run this substitution, what happens? You end up with dx over 1, the square root of 1 minus what? U squared, but instead of dx, what do you write? So you have du, and what goes on the outside? 1/2, like that. Now, at this point, what do you need to be able to recognize? What is that? That isn't arc sine. What is that? It is not arc. So that what is this? I'll be more specific. What is that? Just inside the circle, what is that?
That's the
Derivative of arc sine. So therefore, if you're integrating the derivative of something, where are you?
back of the original.
Yes, exactly. Very good. So this is 1/2 of sine inverse of u plus c, but what's u? So it's 1/2 sine inverse of 2x plus c. What was the crucial element here? What did you have to know in order to do this one the most efficiently? What do you have to memorize? This is one category of things you have to memorize. You have to memorize. The derivative of inverse trig functions. The derivatives of inverse trig functions. You must memorize the derivatives of inverse trig functions. What do the directions on this one say? They say evaluate the integral using partial fractions or trig substitution. So let's say you didn't have to use those. If you didn't have to use those, could you use the same method we used before? Yes. If we wanted to use the same method we wanted to before, what is u going to be on this one? 3x. Exactly. So u is 3x. So du is 3 dx. So dx is du over 3. So what do you end up with? The integral of 1/3 1 over the square root of 1 minus u squared du. And do we recognize what that is? Yeah. So that's going to be 1/3 sine inverse of u plus c. So that's going to bring us to 1/3 sine inverse of 3x plus c. Now that's the quick method. That's not the one they wanted you to use. They're giving you one that works out well, but they wanted you to use trig substitution or partial fractions. Is this a partial fraction problem? No, it's not. This is not a partial fraction problem. So if we were going to use trig substitution on this one, if we wanted to use it, I'll just copy it over again so we have it again. We'll do it again. What trig substitution should we make? Tangent or what? What do you want to do? Okay, so someone tell me what should be substituted in for what specifically? What's the thing we have to take care of at that point? The dt. We have to turn it into dt. That's dx. So what do we have here? If we do the derivative here, we have 3 dx is equal to what? Cosine t dt. Is that correct? So what does dx equal? Cosine t dt over what? Over 3. So when we plug this in, we end up with 1 over, what's 1 minus sine squared? Cosine squared. Instead of dx, we have cosine t dt over 3. Is that correct? Okay. So we end up with the square root of cosine and cosine cancels, and you end up with 1/3 the integral of just dt, right? When you integrate that, what do you end up with? 1/3 of t plus c. But what does t equal? Oh, what does t equal? Sine inverse of 3x. So you take this, You plug it in down here and end up with 1/3 sine inverse of 3x plus c. Is that the same thing we got before? It is the exact same thing we got before. There's two different ways. If you remember what the trig, what the derivative of the inverse sine is, you can do it about half the time. Otherwise, this is fine too. You can cruise through this. That's absolutely doable. If you don't remember, that's fine. Totally fine. But just remember on the test, if I say use a specific method, you should use that specific method. That being said, if you totally blank and you're like, I have no idea how to do it this method, I'm going to try a different one, you can. That's totally fine. But what I recommend you do, skip that question and come back to it. Do everything else first. Don't spend like 20 minutes trying to do like the harder method, because the method I point you at, generally speaking, will be the quickest one. You notice you're like, okay, how about maybe we let u equal e to the x? So what's du equal? E to the x dx, right? So you end up with the integral of u over u squared minus 1. But then what gets multiplied right here? What's dx equal to?
Du over
Dx is equal to du over what?
dx.
E to the x. So you get du over e to the x. You might freak out here for a minute. Why? There's an x and a u in there, right? But what does e to the x equal? So that's u over u squared minus 1 times du over what? U. So you end up with the integral of 1 over u squared minus 1 du. How do you integrate that? Yeah, u plus 1 times u minus 1 du. And then you have PFD time. Yay. It's a cool question. Okay.